As the demand for energy efficiency continues to rise, both homeowners and businesses are seeking solutions that promise to reduce electricity bills and optimize power consumption. One such product that has garnered attention is the home use and commercial use Power Saver Superpower Energy Saving King Air Conditioning Meter Power Saver. Marketed as a cutting-edge device capable of delivering significant energy savings, this power saver is designed to operate in both residential and commercial environments. However, despite its appealing promises, there are critical factors that potential buyers should consider before investing in this technology. The promise of energy-saving boxes. Energy-saving boxes, like the Superpower Energy Saving King, are designed to function as secondary power sources that operate in parallel with the main electrical supply. The underlying principle of these devices is to improve the power factor, stabilize voltage, and reduce the amount of wasted energy, particularly for high-consumption appliances such as air conditioners. By optimizing the flow of electricity and reducing surges, these devices aim to lower the active power, kWh, demands, which in turn should reduce electricity bills. Proponents of these devices often compare their function to that of renewable energy sources, such as hydroelectric power or wind energy, which supplement the main power supply. However, unlike these traditional sources, energy-saving boxes do not require access to natural resources but instead rely on electronic circuits that purportedly create an auxiliary power source. A popular example is the Joule thief circuit, which is said to ease the load on the electrical system by generating cold electricity. The concept of cold electricity. One of the more controversial claims associated with devices like the Superpower Energy Saving King is their ability to generate cold electricity. This concept, which is not widely recognized by mainstream science, suggests that these devices emit a unique form of electricity that is particularly efficient for powering electronic devices. Proponents argue that this form of electricity is mixed with the alternating current, AC, supplied by the main grid, leading to more efficient energy use and reduced consumption. The theory behind cold electricity is linked to the idea that raw matter, condensed from the ether, retains certain elastic and reflective properties that can influence electromotive force. Over time, as materials like copper coils degrade, similar to aging transformers, this tension is said to weaken, which is where high-quality energy-saving boxes step in to provide a more stable and efficient electrical supply. Quality concerns and market realities. Despite the theoretical benefits, the actual performance of these energy-saving boxes is often called into question. The quality of these devices largely depends on the electronic circuits inside and the components used. Unfortunately, the market is flooded with products of varying quality, many of which are prone to counterfeiting or simply do not live up to their advertised claims. This inconsistency in quality is a significant concern, as a poorly constructed device can not only fail to deliver the promised savings but may also pose a safety risk. Additionally, the longevity of these devices is often limited. Manufacturers are unlikely to create a device that functions well for 5 to 20 years, as this would reduce the need for consumers to purchase replacements. Typically, users might find that these devices need to be replaced after just a few months of use, which diminishes their cost-effectiveness in the long run. The role of power factor correction. At the heart of many energy-saving claims is the concept of power factor correction. The power factor is a measure of how effectively electrical power is being used, with a higher power factor indicating more efficient use of electricity. Devices like the Superpower Energy Saving King are designed to improve the power factor by reducing reactive power, which does not perform any useful work but still contributes to the total energy consumption. While improving the power factor can lead to some energy savings, the extent of these savings depends on the specific conditions of the electrical system. In residential settings, where the power factor is generally already quite high, the impact of such a device may be minimal. In commercial settings, where large motors and heavy machinery can cause a lower power factor, the potential benefits might be more significant, but this is not guaranteed.